Alright, so you've already done, okay, so we've already done the first one above, or first one in the very top. We did that together as a class. So now the next thing we're going to do is we're going to talk about number 2, okay? Gosh dang it. Alright, so it says, it's marked for you, AR, angle A is congruent to angle R. And then it says angle B is congruent to angle S. It says, are these two similar, okay? That symbol means similar. Okay, remember, congruent is this symbol, okay? Similar is well, sorry for the play on words, similar to that, except for we don't have the equal sign. It's just the little tilde, okay? So now it's saying, are they going to be similar? Well, in this situation, this is going to be a yes, okay? And it's based off what we call the angle-angle theorem, okay? So basically what it is if you have two angles congruent, then the third one is going to be congruent. And if that's the case, then we're going to have something similar, okay? Now what you can do as well, you can almost set up like your ratios or try to find your scale factor. So in this situation, you would set up, you're trying to find, I guess, these two, okay, the RT and AC. So what you would do to find the scale factor is you would have, let's see, you would have RS over, let's see, AB. And K is your scale factor. Okay, so we have RS over AB. So then what we'll have is A prime B prime is equal to K times AB, and then that is, which is equal to RS. Okay, well, in this situation, what happens is, so essentially what we're getting is A prime B prime is equal to RS. Okay, so what it's saying is, after we dilate this particular one, we're going to get this side is going to be after the dilation. Okay, so after dilation. So after we dilate this triangle, AC is going to be the same. Or it's going to be proportional to RT. Okay, so after we get that, they're going to be proportional. Then we're going to notice that they are going to be similar. Okay, if they are proportional, they are similar. Okay, so you guys try to look at the next one, see what you get. So in this situation, K is the scale factor, so we multiply K times AC is equal to RT. The dilation map of ACB maps to to A prime, B prime, C prime, and A prime, B prime, C prime, the triangle, is congruent to RST by angle side angle. So if those two are correct, then, or since they're these are congruent, and this prime maps to the original, then yes, we do have, I wrote congruent, but really it is similar. So there are going to be similar triangles. So now these are all the theorems that we talked about before and when we did proofs. Angle, side, angle. Angle, angle, side. Side, angle, side. Side, side, side. Hypotenuse, leg. Well, these are the same type of things, except for they're dealing with similar stuff, not congruent. That's nothing but triangle congruency. This is all similarities, okay? So we have the AA theorem. So if we have two angles of a triangle congruent to two angles of another triangle, then the triangles are similar, okay? So if you know that two of the angles, and notice they are two consecutive ones, okay? Well, almost every triangle has two consecutive ones, okay? So basically you have as long as you have two angles that are congruent, that means the whole thing are going to be similar, okay? So, let's take a look at number 4. Actually, no, let's skip number 4. You don't have to do number 4. The side, side, side is basically saying if the corresponding sides of two triangles are proportional. Now notice they're not congruent, but they are proportional. Then they are similar. Okay, and proportional means, and you notice here how they have things set up. Okay, what it's saying is, as long as you put this side that I have in green over this side that I have in orange. Okay, if you put them over each other, you're going to get some number. Okay, let's say this purple one I'll put over this red one. If I make this into a fraction and they're the exact same number, then they're going to be what we call proportional. Okay, notice too, it talks about its corresponding sides. Okay, so in these triangles, when I talk about AB, its corresponding side, which is basically the same side but on a different triangle, is going to be this one here. Okay, those are corresponding. So I'll put one over the other. And notice too, when we write proportions, sorry, I had to sneeze. When we write proportions, notice how they write it here. Okay, on the top, they are all the left triangle. And we have the bottom, those are all the right triangle. Or triangle on the right, sorry. Not a right triangle. When we write proportions and when we set up proportions, they have to be almost identical to what we're doing, okay? So what I'm saying is, on this one, they have left triangle over right triangle. Let's see, so we have left triangle over right triangle, left triangle over right triangle, left triangle over right triangle. Okay, they're all set up very similar or as the same as each other. Okay, so be sure when we write proportions to do that. Then we have the side angle side theorem. Okay, so in this one it says if one triangle is congruent to an angle of the second triangle. Okay, so the angle is congruent, but the sides are going to be similar or proportional. AL. So they'll be proportional. Let me rewrite that. There, rewrote it. It's proportional. Okay, so again, we're going to have two angles be the same, or one angle be the same, but then two sides are going to be proportional. And again, that's setting up two sides, and when you set them up, you get the same fraction after you simplify it. Okay, and this next one we'll talk about we'll talk about that. It says angle ABC and DEF, are they similar? Well, let's set things up. So AB is going to be over DE. Okay, so in this problem, let's write that. So AB is going to be 3 over DE, which is 4/5. Okay, so now let's take a look at another one. So we're going to do BC and FE, okay, or EF. See, BC, EF, and I can even look at the way it's written to kind of tell me which one's going to be corresponding to the other. Okay, so we have BC over EF. So BC is going to be equal to 4 over 6. Okay, if we simplify that, that's 2/3. Okay, so now let's take a look at AC and FD. So we have AC over FD. So we have AC, which is 5 over 7.5. Okay, so we take a look at these and say, okay, is this as most simplified as we can get? Okay, so they have to be equal to each other. Each one of these have to be equal to each other. Not that one, this one. So let's take a look at that. So in the first one, yeah, it's 3 over 4.5, but that actually can simplify to 2/3. You're probably asking yourself, how's that possible? Well, 1.5 goes into 3 2 times, and it also goes into 4.5 3 times. So that's going to be 2.2 or 2/3. This 2 is also going to be 2/3. Now the next one, you can also this 5 over 7.5. It too is also going to be 2/3. 2.5 goes into 5, and 7.5 2/3. So all three of these are the same. So since all three of these are the same, then yes, these two are going to be similar. Okay, and if you want to add a theorem, it's because of the side being similar. Okay, so and all three of these proportions are similar. Now, if you want to be able to know how to do it, how am I supposed to know the 1.5 and the 2.5? Well, you can actually type this into your calculator and actually do it for you. Okay, all you have to do is type in 3 over 4.5 and then hit enter, and then it'll give out a simplified fraction for you. Or if they give it a decimal, then you change it, convert it to a fraction, and then it'll give you 2/3. Okay, try the next one. Set it up yourself and see what you get. So the first thing that we have to do, you look at that Q is in both triangles. Okay, so there's your angle for both triangles if you separate them. Okay, so if you separate them, Q is going to be right there on both of them. Okay, so in this particular one, we have the included angle. So now let's look at both of their sides here. Okay, so we'll both look at these sides on right here and here, which both are going to be PQ. Okay, so we put PQ over RQ. Okay, and a lot of it is based off of this here. Okay, PQ and RQ. So we have 18 over 12, which equals 3 over 2. So then I look at SQ and PQ. Okay, so then I set that as a proportion or one over the other, and notice too, the green one I put on top, the purple one I put on bottom. Okay, so that's like I showed that just to show you guys that I'm keeping it the same. The green on top, purple on bottom, because you have to make sure they match. You can't put green on top, purple on bottom on one, then switch it up and do the purple one and green one, purple on top and green on bottom. You can't do that. Okay, both end up with 3 over 2. So both end up with 3 over 2, and they also have a Q in common. So technically, if we needed a theorem, it would be the SAS similarity theorem. You guys try the next two and then come back. So if you look at number 7, if you set it up, and basically all I did was do AD over AB, set that over each other. Then I would come back and do DE over BD. Then I'd come back and then I would do AE over AD. Okay, so I basically just kind of did in order of what they showed us. So then, as I set them up as a proportion, or I set them up as a fraction, I get 3/4 on all of them. Okay, and you'll notice too, I got 3/4, 3/4, 3/4. Since they all match, yes, this is a similar. Okay, so this first one is yes. Now I'll go to the next one, number 8. You'll notice I have the answers 2.4 over 2.4, which technically would be just equal 1. And then the next one, you do 1.8 over 1.4. I'll do that real fast. And you end up with, let's see, 9 over 7. These do not match. Since they don't match, and this one we don't know, since they don't match, they are not similar.